In this question, we want to know if the system given by those three equations and three unknowns is consistent or inconsistent. So when given a situation like this, we know that there are 8 possible scenarios. So in order to determine which one it is, we ask ourselves the test to determine which case applies to the 3 planes. The number one question, are any of the normals parallel? So we ask ourselves, are any of the normals parallel? Well, we can see that our normals are 3, -1, 4, 2, 1, 1, and 2, 5, -2. So none of the normal vectors are parallel. Because none of the normal vectors are parallel, we have 3 possibilities. Either we have one point of intersection, one line of intersection, or no intersection at all, a triangular prism. Going back to our handout, we see that if 0 normals are parallel, we either have one solution using matrices, no solutions using matrices, or an infinite number of solutions using matrices. Let's see which possibility we have here. The way we're going to figure it out is to literally use matrices. So we're going to solve this system by setting up a matrix, augmenting it on the right, and then doing our elementary row operations. Well, you can see that we multiply row 1 by 2, row 2 by 3, and row 3 by 3 in order to get 6's in the left-hand column. We can then subtract row 1 minus row 2, row 1 minus row 3, and as well we can reduce row 1 back to its lowest terms. And we end up with this eventuality here. Now, if we're pretty clever, we can see that 0, -5, 5, 5 is just begging to be reduced to 0, -1, 1, 1. So we do that with that second row. And now we can see that it'll be pretty easy for us to eliminate this middle term by multiplying that row by 17. And we do that. And we're now in a position to subtract row 2 minus row 3, and also to reduce row 2 back to 0, -1, 1, 1. And we end up with this right here. Now looking at that, we can see that 3z equals 6. We can solve for z and put it back up into the previous row. And then we can solve for y. So 3z equals 6 means z equals 2. Going into the one row higher, we see -y plus z equals 1. Ultimately implies that y equals 1. And a z value of 2 and a y value of 1 plugged into the top row ultimately means that x equals -5. And so we've got one point of intersection at -5, 1, 2. And so what that means is that we have actually a consistent system. It's a consistent system because the one point of intersection on all 3